Hello, welcome back to another episode of Math with Haas. You are watching Precalculus, Season 2, Episode 8. We are continuing our investigation of trigonometry. Now, in the last video, we saw that sine of theta was equal to y over r, and cosine theta was equal to x over r. Now, for both of these, we can multiply by both sides by r. And so we get that y is equal to r sine theta, and x is going to equal r cosine theta. So what that means is the x and y coordinates of our circle, if that's a circle, that looks terrible, but we'll run with that. Actually, no, we won't run with that. It's a little better. So here's our theta, here's our radius. So the claim then is our x and y coordinates at this point here are going to be r cosine theta and r sine theta. In fact, that was how we derived our two trig functions here, sine and cosine. And so what we're going to do now is ask the question, how do we find points on a circle? And in fact, there are some set values on the circle that give us really nice numbers, and they show up all the time. And so where we are headed is investigating what's called the unit circle. Alright, so the unit circle. This is the core background idea perhaps behind trigonometry, is this idea of a unit circle. So the unit circle is of course a circle, and the radius is equal to 1. So then our equation for the unit circle is x squared plus y squared is equal to 1. That means for the unit circle, if x is equal to r cosine theta, then since r is 1, x is just going to be cosine theta. And in fact, we have something similar of y being sine theta, because again, r is just 1. Now, we can start defining values, right? So, here's our unit circle. We know the radius is 1, and we know that right here, since we start on the positive x-axis, this is 0 pi, or just 0. And we know the points for this is 1 comma 0. So that means this information right here, this point tells us that cosine of 0 pi is going to equal 1, and sine of 0 pi is going to equal 0. Or in other words, cosine of 0 is equal to 1, sine of 0 is equal to 0. And we can define our other points here. If I go all the way around the unit circle one time, that is 2 pi, and so that will also be true. If I plug 2 pi as my angle in the cosine, notice the x coordinate is 1, so that means this is going to equal 1, because the x coordinate is 1 and cosine is the x coordinate. And similar, sine of 2 pi is going to be 0. And if we recall, 0 and 2 pi are coterminal angles because they are literally the same xy coordinate. It's just we go around the circle one time. In fact, if we go around the second time, that brings us to 4 pi. 4 pi is coterminal with sine and cosine. Or not with sine and cosine, but I meant with 0 pi and 2 pi. So cosine of 4 pi would also be just 1, because it's right here, same xy coordinate. If I go halfway around the unit circle, well, that's just pi. And for pi over here, we know that coordinate is going to be negative 1 comma 0. So that tells us that cosine of pi is going to equal negative 1, and sine of pi is equal to 0. For our top here, we're halfway in between 0 and pi, so that's pi over 2. And for this coordinate, it's going to be 0 for x and 1 for r, or 1 for y. Now, you're probably wondering, how am I getting these values? This 1 and 0, this 0 and 1, and negative 1 and 0. Well, let's remember this. This here is the positive x-axis, and our unit circle has a radius of 1. So if I go out from here all the way to where it intersects, where the circle intersects our positive x-axis, that has to be a length of 1 because the radius is 1. That's how I get this coordinate. Similar here, radius is equal to 1, so when I go from the center circle out to the circumference, I should go a distance of 1. We get a negative 1 here, going out to the left because this is now the negative x-axis. So with this information, looking at this here, we know that cosine of pi over 2 is going to equal 0. Sine of pi over 2 is going to equal 1. So just note, right, the x-coordinate is cosine. So when you plug pi over 2, that angle, so that's the angle all the way up to here, that's pi over 2. When I make that angle, plug that in, you get 0. But when you plug in the sine, you get 1. Down here, halfway in between pi and 2 pi is 3 pi over 2. And for 3 pi over 2, we have 0 again for cosine, and we'll have a negative 1 because this right here is a length of 1. Alright. Now the next angle of interest is right here in the middle. Suppose I was to go cut this directly in half. Well, halfway between 0 pi and pi over 2 is pi over 4. Alright. Now, if we want to figure out what are the xy coordinates here, let's go ahead and make a bigger diagram. So, here's our quarter of a circle, and we're chopping this straight in half. Well, that's a terrible one. We're chopping it straight in half. That means this is a pi over 4. There's our angle. Now, when I imagine drawing a right triangle here, the claim is that this side here is going to be the same length as this side. And the reason why we know that is because our triangle here is a 90-degree triangle, and since we're cutting 90 degrees perfectly in half here, that means this angle has to be the same as this angle, and we know that this one is pi over 4, so that means this one has to be pi over 4. So pi over 4, we should know pi over 4 is equal to 45 degrees, just in case you weren't aware of that. So 45 plus 90 is 180. Don't forget, all three angles of the triangle have to add up to 180 degrees. Now, since these two angles are the same, that means these two sides have to be also the same because it's an isosceles triangle. So we are using a lot of geometry facts here. In fact, this is going to be a very geometry driven video. So when we want to consider our xy coordinates here, right, we can note that these two sides are equal, so that means x is going to equal y. Okay, and our hypotenuse is just a radius, and that's equal to 1. So if I use the Pythagorean theorem, we have 1 squared is going to equal x squared plus x squared. It could be, we would normally write x squared plus y squared, but x is equal to y. I mean, we could have started right here. I was just thinking, well, let's save a step, but then I just wasted a minute explaining my step I was saving, but we'll roll with it. So we get 1 squared is equal to 2x squared, or 1/2 is going to equal x squared. 1 squared is 1, so divide both sides by 2, and now we'll square root. Boom, boom. So we get 1 over square root 2 is equal to, let's undo that, can't do that. So plus or minus 1 over square root 2 is equal to x. Whenever you square root, do not forget that plus or minus. Now, we're going to rationalize the denominator. That means x is going to equal plus or minus square root 2 over 2. So to rationalize the denominator, we'll do our scratch work over here real quick. So we multiply by root 2 over root 2, giving you root 2 over 2. Because square root 2 times square root 2 is square root 2 squared, so that this square root and the square cancel out, giving you 2. Alright, so if x is equal to plus or minus square root 2 over 2, we have to remember now that we are in the positive, well, we're in quadrant 1, which means both x and y have to be positive. So that tells us that x is equal to y, and that's equal to square root 2 over 2. Alright, so our coordinate here is square root 2 over 2, comma, square root 2 over 2. Now that's looking quite nice. Alright, now, so that tells us that cosine of pi over 4 and sine of pi over 4 are both equal to square root 2 over 2. This is exciting. Look at all those numbers. Alright. Now, when we look at this, well, I can make an angle over here that is also cutting this in half, right? 45 degrees, or a pi from, we think from here to here, that's a pi over 4. Right? So if I cut this in half, then, well, pi over 2 plus pi over 4 is 3 pi over 4. So that means this angle here is 3 pi over 4. And we already proved that when this triangle here, right, if x and y are equal to each other lengthwise, then we just did all this work over here and showed it square root 2 over 2. Now this is where the plus and minus becomes very important, because now x is in the negative. X is negative. We're in quadrant 2. So we're going to have a square root 2 over 2 that's negative for x, but square root 2 over 2 that's positive for y. And we can continue this, you know, just break off the other, across the other quadrant. So in this case, if we take pi, add a pi over 4, that gives us a 5 pi over 4. And our xy coordinates here, again, it's a 45-degree angle from pi to 5 pi over 4, or to pi over 4 angle. Right? And that means we again have our isosceles triangle. So to claim this, we'll have negative root 2 over 2, comma, negative root 2 over 2. And this is precisely because both x and y are in the negative, are both negative, because we're in quadrant 3. Quadrant 4, x is positive, y is negative. So that means if we add a pi over 4 here, that will give us 7 pi over 4. So for 7 pi over 4, we have root 2 over 2, comma, negative root 2 over 2. And remember, for all these values, the x-coordinate is your cosine value, and the y-coordinate is your sine value. So sine of 7 pi over 4 is negative root 2 over 2. Alright. Now, there's another important angle over here, and it's called pi over 6, and there's another one called pi over 3. The question is, what is the xy coordinates for pi over 6, pi over 3? And if we figure that out, we can figure out 6 more values. This is super exciting. Alright. So, let's see here. So pi over 6, let's work on that question now. So, this is going to be a little more involved. Okay. So, here's our circle. So note that pi over 6 is the same thing as 30 degrees. Okay. So here's our angle. Here's our pi over 6. And we can draw another line over here and go straight down, make a nice triangle. Now, because of our construction here, we know this length is equal to this length because it's r, and that means this angle here is going to be the same as this angle. That is a pi over 6. So that's pretty cool. And the next thing we need to know is since the top right triangle here, this one, we have 30. This is of course 90. That means this angle up here is a 60-degree angle. 60 degrees, same thing as pi over 3. So that means this angle is, let's use another color. So that is pi over 6. So if we think about this, the top triangle is a 30, 60, 90. The bottom one is also a 30, 60, 90. So that means this, I guess we'll use 3. So that's equal. So when we think about our overall triangle now, we have a equilateral triangle because this angle is 60, 60, 60. Or I think pi over 3, pi over 3, pi over 3. I just realized I wrote pi over 6. That should have been pi over 3. Silly me. Alright. So with this, that means, right, well, we already mentioned that this is r. So if we cut this length here in half, which is what we're doing with the x-axis, that means this length, let's use green. Make this as colorful as we can. So that means this length here is y, and this here is also going to be a length of y. Alright, so this tells us then that one note, since each angle is a 60-degree angle, that means this is an equilateral triangle. And since this is an equilateral triangle, then we know that if we add this length plus this length, we get 2y, and 2y has to equal r. And that means then that y is going to equal r over 2. Okay. So, that's awkward. We'll do it this way. Alright, so if y is equal to r over 2, then we can redraw our top one. So here's our top angle. So here's pi over 6, pi over 3, here's this. This is a r over 2, this is a r, and this of course is this x. So with this, we know that r squared is going to equal r over 2 squared plus x squared, right? Pythagorean theorem. And we can solve this. So r squared is going to equal r squared over 4 plus x squared. So if we subtract r squared over 4 from both sides, r squared over 4, that tells us that if we have 1 whole r squared minus 1/4 r squared, that leaves us with 3/4 r squared is equal to x squared. And we can square root that, right? So that means x is going to equal 3 over 4 square root r squared. And the funny thing is, why am I writing all these r's? Because r is equal to 1. So, oops. X is going to equal square root 3 over 2. So this, what happens here is we have root 3 over a root 4 and then a root 1 squared. So who cares about that, because that's just 1. Alright, it's looking nice. So if x is equal to root 3 over 2, we can now figure out what y is, right? I mean, if we, well, actually y here is going to be a half, right? If r is equal to 1, that means this is a half. Alright, so it's not too bad at all. We got our x and our y coordinate here. So we find our, oops, there's our So that means for pi over 6 we get square root 3 over 2 comma a half. I think we should probably make this bigger now. This is getting crowded. Alright. Let's zoom out. That was actually a really decent circle. I'll probably never make a circle as lovely as this one. So pi over 4, we said is root 2 over 2, root 2 over 2. Here's our pi over 6, and that is root 3 over 2 comma 1 half. And then the claim I'm going to make is this here is going to be a 1 half comma root 3 over 2. Because if we think about it, it's just a reflection of our right triangle here, because it's still the same 3D, 60, 90 triangle. So I'm going to start filling out our unit circle. So we got here 0 pi, comma 2 pi, and it's just 1, 0. And then if we think about our pi over 4 a moment, if you take pi over 4 and add pi over 4, that gives you like a pi over 2. If you add pi over 4, well, you can also think pi over 4 or pi over 2 as 2 pi over 4. Add pi over 4, that gives you your 3 pi over 4. So this is root 2 over 2, root 2 over 2. That has to be negative. And if you take 3 pi over 4, add a pi over 4, that brings you to pi right here, which was negative 1, 0. And then if you add a pi over 4, that's right here, that's 5 pi over 4, negative root 2 over 2, negative root 2 over 2. Add a pi over 4 brings you to 6 pi over 4, or 3 pi over 2, so that's 0, negative 1. Add a pi over 4, that's 7 pi over 4. That is root 2 over 2, comma, negative root 2 over 2. Alright, then if you add a pi over 4, that brings you to 2 pi, or 8 pi over 4. And similarly, if we start pi over 6, and you add pi over 6, that gives you 2 pi over 6, which is right here. If you add a pi over 6, that gives you 3 pi over 6, which is pi over 2. So notice, if you just add multiples of pi over 6 and pi over 4, you're going to get everything on the unit circle. If I add pi over 6 to 3 pi over 6, that's 4 pi over 6, or 2 pi over 3. 2 pi over 3 is going to look very similar to this pi over 3. We'll have a negative a half, comma, root 3 over 2. X is negative because we're in quadrant 2. Y is positive because quadrant 2. In this case here, if you add, so this was 4 pi over 3, or 4 pi over 6, add a pi over 6, 5 pi over 6, right here, 5 pi over 6. That will give us negative root 3 over 2, comma, 1 half. Pi over 6 plus 5 pi over 6 is 6 pi over 6, which is right here. Add pi over 6, that brings us to 7 pi over 6. And this will be negative root 3 over 2, comma, negative 1 half. Add pi over 6, that's 8 pi over 6, or 4 pi over 3. This is negative 1 half, comma, negative root 3 over 2. So this was 8 pi over 6. Add pi over 6, we're at 9 pi over 6, or 3 half. So add pi over 6, that's 10 pi over 6, or 5 pi over 3. So this is going to be, oh, this is going to be positive a half, comma, negative root 3 over 2. 10 pi over 6 plus pi over 6 brings you to our last value, 11 pi over 6. And so this will be, oops, root 3 over 2, comma, negative 1 half. And that, YouTube, is the unit circle. Marvelous. We can put the degree angles on here too. So this is 30 degrees, 45 degrees, 60 degrees, and then let's see here, this is 120 degrees, 135 degrees, and 150 degrees. Alright. Let me just keep going. Let's see here, 180 degrees plus 30, that gives us 210 degrees. 180 plus 45 is 225 degrees. 180 plus 60 is 240 degrees. This is of course 90 degrees, 180 degrees, 270 degrees, and then let's see here. So take 270 and add 30, that's from here to here. That will give you 300 degrees. 300 degrees. 270 plus 45 is 315 degrees. 270 plus 60 is 330 degrees. Alright, so there's our degree angles on degree values on there also. In general, you will want to memorize the unit circle because it's very important. Because you need to be able to say what cosine of 7 pi over 6 is off the top of your head. Well, 7 pi over 6 is going to be root 3 over 2. Or 7 pi over 6? No, that's negative 3 over 2. Oops. Yeah, I was thinking quadrant 4 by accident. Quadrant 3. But you have to have these memorized off the top of your head because these quantities show up all the time in calculus and whatnot. And so when you encounter them, you just need to be able to, just at the snap of your fingers, have that down. So how I remember it is, I just remember, I think the pi over 4, any denominator that has a 4 in the denominator, that's a weird sentence I just uttered. Any denominator that's 4 is a square root 2 over 2, square root 2 over 2, because the xy coordinates are the same. And so the way you keep track is just the plus minus. So when we think about, so look, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, it's all root 2 over 2. Quadrant 1, x and y are positive, so these are positive. Quadrant 2, x is negative, y is positive, so that means cosine's negative, sine is positive. Quadrant 3, they're both negative, so x is negative, y is negative, so sine and cosine are both negative. Quadrant 4, cosine is positive, y is negative because, or cosine is positive, sine is negative because x is positive and y is negative. So that's where the sign patterns are coming from. With the pi over 6 and the pi over 3, how I remember them is pi over 6, the x coordinate is larger, we go further out in the x direction, whereas when we think of pi over 3, we go further up in the y direction. Pi, or square root 3 over 2 is the larger value of these two. Square root 3 over 2 is larger than pi, or 1/2. Keep on say pi, but yeah. So I just keep that in mind. If square root 3 over 2 is the larger value, then I know this length here in terms of the x direction has to be square root 3 over 2, whereas here the x is shorter. It's a shorter length in comparison to y, so it has to be the half. Alright. So that's just one way. Alright. That is one way kind of keep track of these. Alright. With that, we'll leave us with a couple examples before we end our video. So if I ask a question of what is cosine of 11 pi over 6, well, I can look at the unit circle if I don't have this memorized yet and look, oh, x coordinate is square root 3 over 2, so square root 3 over 2, done. Sine of 5 pi over 4, well, that is going to be negative root 2 over 2. I just remembered, well, 5 power 4, that's quadrant 3, and then I just remember, since we have a 4 in the denominator, that means that we have to have a root 2 over 2. Alright, so the PDF homework assignment is just going to be drilling sine and cosine based off the unit circle. I recommend that you first focus on memorizing unit circle, and then you can use the PDF as a way of drilling yourself. Okay. And with that, I'm going to say thank you for watching this video. If you've enjoyed our content, please subscribe. Consider supporting us on Patreon. And thank you for joining the math party. I will see you next time.